Hello guys, welcome back to another video. This will be the second video in the series, how to get your first tech internship. And in this video, we're going to be focusing on coding challenges, how to do well in your interviews, and what interviewers are really looking for when they're giving you any kind of technical coding challenge or when you're just sent a coding screening. So let's go ahead and get started with my favorite website for practicing coding challenges, leetcode.com. So basically leetcode.com is a website where you can practice for these interview questions completely for free. You can filter by difficulty, what kind of problem you want to practice. So if you want to practice things with arrays or strings or hash tables. But wait, if you're asking yourself, what even is a coding challenge? Basically, when you start applying for companies, the way that a lot of companies filter these days is they'll send you a coding challenge. So that'll be a little written problem that you need to solve with certain runtime complexity and space complexity. Usually they only care about runtime, but sometimes they care about space too. So like I was saying, a really great website to practice these problems is LeetCode because they give you a bunch of free problems that you can filter and just use every day for free. They also include study plans that are all for free. I'm not making any money off this website, but I do use it a lot and it helped me get my first 2 internships. So let's go ahead and just go through what a sample coding problem might look like and kind of how you should talk to the recruiter and act during that coding interview. Because really they're looking for how you think and how you solve problems on the fly. And if you're a good communicator, because if you're a bad communicator and you just sit there the whole time coding, they're going to say, oh, this person's a great engineer if you solve the problem. But will they really know if they can work with you? Do they know how you learn? Those are all things they're looking for in the interviews. And another really important thing to remember when you're going to a coding interview is that they want you to succeed. They want to stop interviewing people and get you on the team as fast as they can. So nobody's out to get you in an interview. They are trying to get you in the company though. So let's go ahead and start this coding problem. Usually there'll be some kind of timer, but with LeetCode, you can just ignore those until you start doing the mock interviews. So remove duplicates from a sorted list. Given the head of a sorted linked list, delete all the duplicates such that each element appears only once. Return the linked list sorted as well. So starting out any coding problem, you're going to want to read the problem or ask as many questions as you can for edge cases, just to make sure you understand the problem. So in this case, it's an easy problem. It'll be pretty simple. We're given a linked list and they want each item in the list to only appear once. They also want us to return the list in sorted order. There's a lot of different ways to solve this problem, but if we're going for optimal runtime and space complexity, we're going to want to do it in place. So we only have to go through the list one time, which would give us a runtime of O of n. So when you're talking to a recruiter or the person who's interviewing you, you can say all these things. If it's asynchronous, it's less important to think out loud, but it might help you get through the problem. So here they've given us the definition for their singly linked class. We're going to go ahead and go down here. And usually whenever I'm doing a problem that has to do with a linked list, I like to print out what's going on so I can see that list in action. And since we're iterating through a linked list and we don't know how long it is, we can do while head is not equal null. And then we can print out the list. And I just like to do this so I can see what's in the linked list. And this is just the way that I like to solve these kinds of problems. Then we're going to return head. In this case, we'll probably return null. So to iterate over a linked list, we're going to go head dot, and we can see here it's head next. To get the next value, I'm going to say head equals head dot next. It's going to help us iterate over that linked list. So we're just going to run the code. And the great thing about LeetCode is you can test, okay, I want to see if this code does what I think it does, and you can run the code here. And then when you submit it, that's when it actually tells you about how good or bad your runtime complexity was. So we can see in this case that we have the list here, 1, 1, 2, and our desired result would be 1, 2. And our output was 0 because what we did is we iterated through the linked list until we got to null, and then we returned it. So there's a lot of different ways to solve this problem. The way that I'm going to do it is I'm just going to have 2 pointers. So I'm going to have 2 different list nodes. And this one will equal head. And this list node will be pointer 2. Another really important thing to remember for a coding challenge like this is that you might not actually have to solve the problem to get the job. You just want to see how you're thinking. and that you can do things under pressure, you can communicate when you're trying to think through a problem. Because again, they're not hiring you as like a person who can do everything or who already knows everything before they get on the job, but they want to make sure that you're trainable, that you can learn, and that you ask the right questions when faced with a new problem or challenge until you can understand it. Okay, so basically what we're going to do is we're going to have one pointer on the current node that we want to keep and a second pointer that's jumping ahead. So we're going to start with pointer 1 being here. So this will be P1, and then pointer 2 will be one ahead of pointer 1, P2 will equal this one. And then we're going to compare and say, okay, does pointer 1's value equal pointer 2? And if that's the case, then we're going to iterate pointer 2 over until it finds null or finds a node that does not equal pointer 1. And when we find a node that doesn't equal pointer 1, we're going to set pointer 1's node to the first node that does not equal pointer 1. And then we're going to iterate pointer 2 to the next node, which in this case would be null, so we would terminate. Okay, let's go ahead and implement that. And it's a good idea to have out the algorithm in your head before you even start coding. I kind of skipped that step here, but if you do a little bit of pseudocode, it's going to save you a lot of time in the interview and a lot of headache of trying to figure out what's going on. It'll also be a bit less nerve-wracking because you won't be trying to figure it out as you're coding. You'll have a set list of items that you're trying to accomplish with this particular code. Okay, so let's go ahead and do this. First, we're going to say this node equals head, this equals pointer 2 dot next. And then we're going to say, okay, while pointer 1 does not equal null. Okay, and then instead of iterating through head, we're going to want to say pointer 1 equals pointer 1 dot next if pointer 1 dot val does not equal pointer 2 dot val. Equal pointer 2 dot val. Great. And then we also want to say if these two are not equal, we want to say, excuse me, we don't want to say it equals next. We want to say it equals, we want to set the pointer 1 dot next. Oh, why is it doing that? Okay, we want to say pointer 1 dot next equals pointer 2. Because then what we're doing is we're linking pointer 1 to pointer 2 if their values aren't the same. And then we're actually going to say pointer 2 dot equals pointer 2 dot next. So then it'll iterate pointer 2 to the next one over. And we're going to assume here that pointer 2 does not equal null and this, or pointer 2 does equal null, in which case we're just going to iterate pointer 1. So we're actually going to do that in a different space. Let's go ahead and look at this code. So we're saying if pointer 1 does not equal null, then we're going to enter this loop and print out the value of pointer 1. And if pointer 2 does not equal null and these values are not the same, then we're going to reassign the pointer 1 to the pointer 2. And then we're going to say pointer 2 equals pointer 2 dot next. Okay, great. And then we're going to say else pointer 2. Actually, we can just take this out because every time we're going to want to iterate pointer 2 equals pointer 2 dot next. Now, the reason I'm solving this problem like this in place is so you can see kind of how in a real life coding situation, they're going to want you to think through the problem and you're going to have to talk out loud to the interviewer so they know what you're thinking. Yeah, I've solved this problem before, but not immediately beforehand. So that's why it's going to take a little bit longer. And yeah, so each time we're going to iterate through. So pointer 2 is moving along, and then pointer 1 is going to point to pointer 2 when pointer 2 does not equal pointer 1. And we're adding this does not equal null so that we don't get a null pointer exception when it says pointer 2 dot value on a null object. Or pointer 2 does equal null, and then we're going to want to enter and just set pointer 1 dot next to pointer 2. Okay, great. And now we're going to want to say pointer 1 equals pointer 2. So then we're just going to move the value of pointer 1 to this, and then we're going to set here pointer 2 equals pointer 2 dot next and iterate it to null. So let's go ahead and see how this works. Oh, actually, we're going to get a null point for error here when pointer 1. Oh, wait, no, we're not. Okay. We're going to go ahead and see what this returns. It doesn't like that. Oh, next. Yeah, another great thing about LeetCode is that it catches all your compiler errors, so you don't really have to worry about that. Null pointer exception. Cannot read next because local is null. Okay, so we're going to have to say if pointer 2 does not equal null, we're going to iterate, otherwise we're not going to iterate. Yeah, because you can't call next on something that equals null. Okay, let's go ahead and see if this gives us something we like. Oh, so this is probably infinite looping because pointer 1's value never changes, because this should have said pointer 2. So we get stuck at the beginning of the list. And it's okay if during an interview something like this happens, just explain out why it's doing that, and your interviewer will probably be okay. So now you can see that the LeetCode is accepting our answers. A lot of time in real interviews, they won't let you do this. So it's really important to practice on LeetCode and get your fundamentals down and syntax errors down. Dot with your semicolons and spell your nexts correctly, all those good things that you'll get from practicing LeetCode a lot. And now we're going to go ahead and look at the edge cases. So ideally in the beginning of the interview, you'd ask them what the edge cases are. In the case of LeetCode, they list those down here. So the list is guaranteed to be sorted. That's really important because if the list wasn't sorted, we'd have to use some kind of hash map to keep track of all of the different numbers in the list and if they've already appeared, if their count is greater than 1. But since it's sorted, that's really easy in a linked list. The node values are also important because if they give you something that doesn't fit in an integer, you're going to have to use different data types and figure that out. And telling you the range is also important because if you wanted to do a really bad algorithm or an algorithm with a very large runtime, knowing that it's a smaller range would be helpful because then you could do that and probably still pass the test cases. In this case, though, we're going for an O of n runtime, only visiting each element once. So yes, this doesn't really tell us too much because we're only trying to go O of n anyway. And does it tell us how long the linked list has to be? The number of nodes. Oh yeah, this is the length. So it can be from 0 to 300. Let's look at the edge cases. If it's 0, then we're going to get mad here because then pointer 1 will equal null. So we're going to say if pointer 1 dot does not equal null. And the reason we're doing this check so that it does not error out here. We're going to go ahead and put it up here, put it here. And until then, we're just going to set this to null. If it's not null, then it's going to be changed here. And another thing about linked lists, the reason that we're returning the head is because the pointers at the end of this will both be null over here, but the head is still pointing to the first node. And because we're changing the values of where these nodes point to, the actual list is going to change even though we're returning head and head wasn't moving along. Okay, cool. So that should have fixed one of our edge cases. Let's go ahead and run the code again. Oh, I'm redefining a variable. Yes. Thank you. Thank you, LeetCode. Great. And now we're going to use all the sample test cases because LeetCode gives a bunch of sample test cases, which are really useful for helping to debug and getting used to problems like this. With a lot of companies, they'll actually only send you, or all the companies that I've interviewed with have only sent me mostly easy questions for the first round. And then for the second round, which might still be asynchronous, it might still be a coding challenge, they'll send you mediums or hard questions. But assuming you get past those, it's really important in an interview to talk through your thought process so then the interviewer knows what you're thinking. And I believe I already said that a couple times, but it's just really important, so I want to reiterate it. Okay, great. It passes all those test cases. You're going to want to think of other weird edge test cases when you're testing your code in front of the interviewer. So let's say we get all 1 for whatever reason. Go ahead and test that. Okay, cool. And we're going to go ahead and submit it now and see if LeetCode likes our solution. Great. It was accepted with a runtime and a memory. Now that's a pretty bad runtime because it's only faster than 5% of other people. So this is another great feature of LeetCode. It tells you how you were compared to other submissions. And in some cases you get the best and everyone gets the same submission time. But in this case, we can do better. Now, something that I learned in my first internship is that system.out.println actually costs a lot of time. So it takes a bunch of time for it to print that out. So if we comment this out and change nothing else about the code, we can improve our runtime, which is why when you're shipping production code, you want to have some kind of Boolean that undoes all of your comments so they don't print out, because that's going to take a lot of runtime. And also it's like you don't need those jargon being printed if it's the production level code, but it does help us debug here. So now we can see the runtime increase just by commenting out this line, because what it was doing was executing for every single node, and we don't need that when we're submitting it. So now you can see that we're faster than 100% of Java online submissions, which could mean we just reached the top submission, and there's probably other people who are also there because they did the same kind of algorithm. Now, I don't know if I mentioned this, but in LeetCode, you also don't have to use Java. You can use any kind of language here. So let's say you're more familiar with Rust. I've never used Rust, but if you're a Rust kind of person, you can do that kind of LeetCode problem too. Well, that'll be the end of this video on coding challenges. And just to reiterate, the most important thing about a coding challenge and getting ready for all these interviews is to be consistent. So even if you're only doing one easy problem a week, that's much better than doing 0 easy problems a week. Or if you can even do one once a day, that'll be great for your consistency, because you'll just get in the rhythm of doing it, and eventually you won't even have to think about it anymore. And make sure to tune in next week for applying to job strategies, mainly shotgunning out your resume to as many people as will take it to try to broaden your chances of getting an internship and open your possibilities of getting multiple offers. Thank you for watching.